Welcome to today's presentation on Git, GitHub, What's the Difference? My name is Sarah McChesney, and on behalf of ProTech Training, I will serve as your host for today. This presentation will last approximately 45 minutes, with additional time reserved for Q&A at the end. During the webinar, please feel free to enter any of your questions into the question area, which may be found within the control panel in the top right-hand corner of your screen, and our presenter will be happy to answer them. Today's presentation is being recorded, and in the coming days, you will receive an email containing the recording link along with the slide deck from the presentation. Today's presenter is Christine Thompson. Christine is an author, consultant, and instructor with over 20 years experience in the field of information technology. She has extensive experience serving clientele worldwide in the building and improving of enterprise systems. Her combined passion for education and technology is what drives her to focus on enhancing the knowledge and expertise of the individual. Christine ensures the success of her students in achieving their personal goals while delivering on the objectives of their organizations. With no further ado, I bring you Christine Thompson.
Thank you very much, Sarah, and welcome everyone. Thank you for taking the time out of your busy schedules to join us for this discussion about Git and GitHub and trying to understand what these technologies are and highlighting their differences. This is Git, GitHub. What's the difference? I've encountered this question numerous times over the years that I've been supporting this technology. So what I want to do in this time that we have is actually tell the story of both of those, take a closer look at some of the key concepts in working with them, and then walk you through some scenarios, some use cases so that you understand what each piece is doing and how they relate to each other. And that would be basically bringing us to the end. Now, just to do a little bit of an introduction, as the fact that you're here and maybe are aware that there's a growing interest, it's exponential, the interest in the industry around Git and GitHub. So a few questions that come up around this is, are we really talking about the same thing? Do I install GitHub? Is it GitHub that I'm using, or is it Git, or both? What are they actually used for? What's the distinction between these? How do they work, and why on earth are they so popular? So in this session, I'm going to try to answer those questions and also maybe give you some bonus knowledge out of that. So the idea is that from this time that we're spending together, that you would have vocabulary and understanding that you could start making some good decisions about using Git and GitHub, and that even you could look at and start navigating to using Git and GitHub on the job. The approach to this is I will give you some concepts first, teaching you some of the ideas, and then I'm going to demonstrate. So it's not going to be just all me talking. I actually want to show you so that you can actually see things working. And hopefully that will help you actually internalize what we're trying to teach you in this. And then at the end, I'll be able to stop and listen to your questions, and we can have a bit of a discussion so that you can go back to work feeling that you've accomplished something. As I was already mentioned, my name is Christine Thompson. In the slide deck that you'll be getting, you'll also have my email address. So if later on, if you're a bit like me, it's like, oh, I should have asked that question, I want to encourage you to feel free to drop me an email. Let me know you attended the webinar and then ask your question. I'll do my best to help point you in the right direction. So part one, without further ado, let's hear about the story. First things first, Git itself is a version control system. What do we mean by a version control system? Well, this is technology that helps us track and manage our changes to files in a project. Now, version control systems have been out for decades, and Git is one of the more recent ones. Regardless of the kind of technology you're using as your version control system, all of them talk about keeping a record of all the versions, so they have the history, they have mechanisms to allow you to do work on a project in a team setting, so supporting collaboration. And that part of what they're recording is not just different versions of your files, but the metadata about it. So who did the change? What was the change? When and where and why did they do that change? So the traceability is an important feature of our version control systems. Now, Git, just so you know, we're coming up on the 16th anniversary of Git, and it was team members from the developers of the Linux kernel, Linux as an operating system. This is definitely an operating system that in enterprises is becoming much more of interest. It works as a server, but it can also work as a desktop. So they were developing the Linux kernel and were frustrated with the tool that they were using for version control. So as soon as they started developing it, if you notice there in the third bullet, they actually started using it. And they continued to create it, but by the end of the year, so the end of 2005, they actually released version 1 to the open source community. And just at the, basically you can see their 15th anniversary last December, they moved up to version 2.30. Now notice that, version 1 to 2, like what software do you know actually got it so right at the beginning? The 30 indicates new features, but there have been no major changes for years. So it's very stable, works really well, and actually the first project that it supported was an operating system, a very big project. Now, just a shout out to the namesake, we have Linus Torvalds from Helsinki, Finland. He invented the Linux operating system. So he spearheaded the project to create Git. It was his idea, his brainchild. Now, just sort of putting it out there because I think this is a cute story. You might be thinking, so is Git mean something in technology? Is it an acronym for something? And Linus is actually quoted saying, I name all of my products after myself. And so you can see that with Linux, and his name is Linus. But with Git, Git is actually a British vernacular term meaning unpleasant fellow. So he was poking fun at himself. When he invented Git, he was was under a lot of pressure, being very frustrated with the tooling they had. And so he was acknowledging that at that point in time, he was very difficult to get along with. And I think it's interesting, he was poking fun at himself, and the joke has lasted now for almost 16 years. All right, so that's Git. What about GitHub? Well, GitHub is actually providing the Git remote repository. I'm getting ahead of myself here. I'm going to explain what that is. But basically, one of the aspects of working with Git is that you need to have a copy of your project on a server that your teammates can connect to. That's referred to as the remote repository. So GitHub, notice 2008, came out over 2 years after Git was available and said, oh, we see an opportunity here. A lot of organizations like the Git tooling, but don't know how to handle the network piece of it. So we're going to offer that up as a service. Now, 10 years after GitHub came out in the market, Microsoft bought it and has continued to develop and grow it. And at this point in time, it's actually held this title as being the largest code host in the world for years now. Notice those numbers, well over 100 million repositories, more than 40 million users. So choosing GitHub as part of your Git solution is a good choice because there's a lot of support, strong community. Now, GitHub as a product has a free version. Anybody in the world can use it, and I'm going to demo that. But they also have licensed accounts so that you can get some extra features and additional support. So most organizations would sign up for an enterprise account. The other thing that I think is interesting is GitHub allows for different visibility. So you can choose to use GitHub, whether it's the free, professional, or enterprise, to have everything locked down only by invitation. Can you see this? But there's also the idea of public. So for instance, open source products make their code available by hosting it on something like GitHub and making it a public repository. Anybody in the world can see what they're doing. Doesn't mean everybody can change it, but this is what GitHub brought to the scene. So the remote repository is a copy of the project, right? All the versions, the history, the metadata, plus the files. And the remote repository is actually required in order to fulfill the collaboration piece of working with Git. Git is about teamwork. So the use cases, as we mentioned with the before with the public-private, that's the read piece. But the write piece is always under the control of the owner of the repository. So this is something that we see. We typically have the read-only for either open source or for production servers to connect to the GitHub server to download the new version of the code. Obviously for teamwork, we want the team members all to have rewrite access so that they can not only read everything, but they can also make the changes as part of developing their code. So the remote repository being fulfilled by GitHub. It's only one element in there, and you don't have to use GitHub to do that. You could host your own network server, but GitHub said, well, wait a minute, it's not enough just to host the remote repository. We actually think when people are working together, they need some tools to help manage their work and do good communication. So one of the offerings that GitHub gave right out of the gate was project management tooling. And this is still being evolved and more features are being added, but a few things to highlight is what we call the issue tracker. This is just the idea that as a team we can create, now I think issues are a little misleading because it sounds like a problem, but issues are like tasks. They're the to-dos. And so I could create a to-do and assign it to different people. And then when it's done, we can actually close it. So we can have basically a tracking of all the tasks that we've done and who's been involved doing it. And in managing the issues, we talk about milestones and labels. This is just a way to sort of set dates and categorize them. Another feature that I really, really like from the project management tooling is the support for code reviews. We'll talk about that in more detail in a bit. And that because GitHub is there to host all these projects, it does support many languages, many data formats, very flexible platform to use. And on top of that, understanding that when you use a tool like this to host your project, you want to make sure everything's secure. So they definitely have enterprise grade security from the free version all the way up. All right, so now let's take a closer look under the covers. So this is an architecture reference model for Git. Git is not just any old version control system. It is what we refer to as distributed version control. By being distributed, what we're saying is, notice here, how many gray cylinders do you see in this picture, right? This is basically saying that everybody has a copy of the project. So notice that team member 1 has a local repository, as does team member 2, team member 3, and then there's yet the main or authoritative copy of the repository being hosted on the server. So we have multiple copies of that. That's a completely different architecture than what we saw in older technologies. And GitHub provides that piece in the middle. You don't have to use GitHub. You could create your own network server and follow the Git instructions to create it as a remote repository. There's also other competing technologies out there in the industry, but GitHub came into the Git picture to say, hey, we can give you space on our network server. And we'll also add in there some of the extras like the project management tooling. But notice that each team member has their own local copy of the project, and when they're ready to share, they go to the network server that is hosted in a location that they can access. All right, so let's take a closer look at Git. Some top 3 Git concepts. If you can get this, you can actually start understanding and working with Git. First things first is creating a Git project. This is on your file system. You actually have a folder that's holding your project. And everything under that folder, all the files, all the subdirectories, and all their files is basically what Git will watch. Of course, you have to turn Git on to say, I want you to manage this project. Now, when you tell Git to manage the files in this folder and all the nested files, what you get is a Git repository. And Git repository, then remember how we had the cylinders, everybody had their local repository? Well, then everybody who has Git on their machine is going to say, I want this project and its files to be managed by Git. Git will actually create a local repository within that project folder. So on my system, I can have dozens of Git projects, each with their own local repository. Another really big piece of Git is number 3. And this was really a new strategy for how to actually support creativity. If I'm working on projects, one of the things I want to avoid is breaking something that already works. But what if I want to add a new feature? What if I actually want to rework some of the existing features? So Git says create a branch so you can isolate the files to safely experiment, make the changes, and only when you're satisfied that what you have works would you actually then move it over to the standard copy that you have. So it's the idea of making multiple copies of the code so you can work in isolation safely without damaging the good copies. So branches are a big focus of working with Git. So let's actually take a look at this. So this is the first demo. I'm just going to navigate down to my desktop here. And hopefully you can see this. I have a project called my Git demo, and I have turned Git on for it. I know it when I see under the project folder a .git folder. So I can see that there. And just so you know, underneath the .git folder are all the resources that Git needs to be able to watch what you're doing and keep track of it. And one of the key things here is this directory called objects. Now, if I just open that up, you're just going to see these numbers and letters and folders, right? These are actually the objects, which is the Git copy of my files. They've been basically encrypted and converted into binary format. So we don't normally go in here directly to read it, but I just wanted you to see that this is the local repository. This is what it looks like. So when I have Git save the file, it's actually making a backup of it. So I have two versions of it. I have one I'm working on and one, the backup of it that Git has. And all of this is local. None of this is doing anything over the network at this point in time. Excuse me. And now I want to show you what it looks like. Most developers aren't going to be working directly on the file system or from the command line. Most of them would use a developer tool. The demo that I'm using, showing you, is using Visual Studio Code. So now I'm going to open up that project in Visual Studio Code. And I don't know of a modern developer environment that doesn't have Git support built into it. Visual Studio Code, Visual Studio, Eclipse, IntelliJ, Jupyter for Python, all of these different tools that are out there do provide support. So this is my Git project that I showed you in the file system. So I'm going to select it and bring it into Visual Studio. Let's close that window there. And you can see that Visual Studio recognized that this is Git. This little icon here with the round circles parting from each other, that is a Git icon. So it detected that this is Git. So now I have the Git support. Here I'm looking at my files and I can see that there's Git. And down here at the bottom, we can see this idea of the branches. Now watch this. I'm on a branch called feature and I'm going to switch to working and look at the files. Notice that we have different files here. Let's go from working to master. These are separate branches that have different copies of the project. Now, if I open up this file, I can see the text. This is on the master branch. Now, if I go over to working, you can see here, it's the same file name, but on a different branch, it has different information. That's the idea of, oh, I started a new branch so that I could update this code and the good working copies on the other branch. And when I'm satisfied that this is good, I can then take my updates from here and put them on the other one. So navigating between the branches, I'm just proving to you that each branch has its own copy of the project, has its own set of files and its own versions of the files, right? So see how navigating the branches is so fast and easy. All right, let's continue. So what does GitHub look like and what are some of its core concepts? So I want you to notice what we were looking at was on the left-hand side of this dotted line. What we want to take a closer look at now is what's on the right-hand side, the GitHub world. GitHub is all about being that server, right? The network server that everybody on the team can connect to. And one of the key ways that we connect to GitHub is using the browser. So that's the web-based GUI that we're going to look at in this demo. But GitHub also offers programming interfaces, so we could automate work when we're talking to GitHub server. In addition to giving us that tooling to be able to use the remote repository, remember that GitHub also gives us communication tools to help us work as a team. That's a big selling feature of GitHub. So concepts that we focus on with GitHub would start with obviously having an account so that you can connect to GitHub as a person and see the projects that you're working on. And obviously what we focus on in GitHub is the remote repositories. Remember, this is why they put Git in their name, is to say you want to have a network server to handle the remote repository in your Git world. We can do that for you. So this is the server stored copy of the project files. Obviously, we have the ability to configure the security for who has access to do what. But the other thing, as we've already mentioned, concept number 3 is just the amazing project management features that they have to make our lives easier and more productive. So we have this thing called pull requests to manage changes. Talk a bit about that in a bit. I already mentioned the idea of having issues. This was about having the tasks managed. So we're coordinating the work, assigning it to different people, and we know what's being done by whom and when. And then being able to have some tooling to get that organized and easy to find and manage. So those are the core concepts of GitHub. So now let's actually take a look at GitHub itself. So I think I have a tab open. Oh, here it is right here. So I'm going to github.com for this demo. And I've already created an account. And so now I'm going to find, I hope, there we go. And there's my ID for GitHub, put in my password. And actually, I'm going to toggle the view. So if I come over here and just look at my repositories, you can see that it says it knows who I am and I can edit my profile. I can have different configurations for things like notifications and other things that I want to do. It gives me an overview with some statistics. So here's basically the main repositories I've worked with, my level of activity with them. So I actually get to have some statistics of the work that I'm doing on my repositories. So nice personal management of my participation in the team. If I come over here to repository, I've already set it up so that the project that I had locally that I showed you was also uploaded onto GitHub. So here is the remote repository copy of it. So if we come in here, if you recall, I had the branches master feature and working. So these are all the branches. And if you recall, if I'm on, basically, if I go over here to working and I can see the files that we have. So I work locally and then I'm going to update GitHub so that now others can see the work. And mentioned about the fact that we have the ability to control who's allowed to make changes. So if I go to the repository settings, I can manage access among other things. So you can see here that this project has 3 different users. So there's myself, the owner, but I've also invited Zatiso and another Zatiso dev 001. So these are different IDs. So there's 3 participants on this project. Now, obviously, not all team members would have the ability to manage the access. We have different roles that GitHub will allow administrators and owners to do this and others just to view it. A couple of other things to highlight. So notice the tabs across the top, mentioned about issues. So you can see here just tracking our work. We can have them closed and we can actually see closed one as well. So you can see in here, these ones are closed and we can read them. Doing code reviews in GitHub is done through what they call a pull request. So we can see one that's open, we can see that one is closed, and this is a project coordination tool, and we'll look at that a bit more. We can also do automation through actions. We can manage our tasks through projects. So if I open up my demo tasks, you can see here that I have the issues organized in a Kanban style of what we're working on now, what we've already done, and what we're going to do. All right, we'll take a closer look at some of that in a bit. Let's go back here. And now we're moving into the third section of this discussion. I want to appreciate the use cases for Git, for GitHub, and having the two together. So what I want to do is demonstrate for you when I'm working locally on my machine with Git installed on my machine, managing a project, how it will actually prompt me to basically, when I make a change to a file, to actually then save it in the local repository. And that making changes safely so I don't mess up good working code would have me doing the changes on a different branch. So we basically, any experiment goes onto a branch that I create, and any branch that's being shared with team members, we know not to directly edit it, that we want to make the changes in a controlled way. And that we can also, I love this number 3 option, we can also tell Git to ignore files. Maybe we've got lots of files in there, but not all of them are really project files. Some of them may be just system configuration files. Maybe some of them are log files for a server. Maybe some are just my notes, right? So there is a feature in Git to actually configure your project to have Git ignore some files. All right, so let's actually watch the resource management. So let's go into my Visual Studio, just like I was a programmer. And I can actually watch Git's view. So in this tool, I open up a view. This is Git seeing that how many changes are pending? 0. Now, if I'm on the working branch, let's try this one. And I'm going to add more to this file. And of course, the tool and the operating system would see that this file is changed. We can see that dark circle saying save this file. Now watch what happens on the left panel when I save this. So I'm going to save the file, and Git is saying I see that one file has changed, and that file is called new file. So Git is actively watching the state of your files. And it's telling us, I see it's changed, but I don't automatically put it in the repository. But I'm going to let you know that I see the change. Do you want to add it into the repository? If you do, then you use the appropriate tooling to get it in there. So you can notice here I have this plus, so I can set it up to go into the repository, and then I can say that I updated the code, so saving the information, and I'm going to go ahead and commit it into the local repository. So here I go. And that puts me back into a stable state. So yes, Git will let me know when I have pending changes that haven't been backed up yet. All right. Now, I said that when we're doing changes, we encourage teams to identify what branch is going to have the good working copy, what branch is going to have the production copy, and then which branches they're going to use to make their changes. So I've got this project set up to model that. The branch called master is for production release version. So I don't directly edit that. It's just, this is the current working version that the server has that we can use to test our code against. Working is the branch that we're going to share with our teammates to say, this is where we're at in our work. We've tested all this code, we've integrated, so this is the current working copy. So I've created this branch called feature, which actually, if I go back to the File Explorer, just to remind you, if I look at working, you can see that there is a difference between, I have a lot of the same files that working has on the feature branch, but I've also got this new feature code that I'm doing. And also, I've got it turned on to show me a little bit of tracking the changes as well in this tooling. Now, what I want to do now is actually, well, that's one file. What I want to do is actually create a new file. So in my tool here, I can just click the plus sign, and I'm going to create new code, right? So this is my new code file, and I'm going to program awesome stuff. Right, just doing this in text so we can focus on how Git is supporting it. And again, Git is telling me, look, you've got one change that you haven't saved in the repository. And it's telling me here it's on the feature branch. So now I am actually going to add it in. So using the Git tooling, let's get that updated into our local repository. Let's get that saved. So this is a brand new file. So add new file and save it in there. And so we know that the file exists, but I want you to know when I look at the feature branch and I look at the files that I have, that new code file does not exist on GitHub. Let's just prove it to ourselves. All of this is happening locally. This is Git doing version control, but doing it locally. It's an extra step to then share it on the server. So if I go back here to code and I select the feature branch, you can see that I don't have that new file, right? So the new code file is not there because we haven't given it to the server. So developers work locally, they save locally, then they get Git to put it into the repository so we have a backup of it, and then they would upload it to the server. Okay, I'm going to show you the uploading it to the server in a moment, but I wanted to show you this really fun file. I've created a .git ignore where I can put in actual file names, folder names, or file pattern names. In this case here, I'm saying, look, Git, any file that ends in .log, I don't want you to track the changes for it. So let's test that. Let's go and create a new file and have it be like my server log. So I'm going to go server.log, right? So I've created this new file and record the test. So imagine the server runs and updates this. I'm just doing it manually so we can see this in action. So I've created a new file, I've edited the file and saved it. Now when I go over to Git, it reports no changes. Remember when I created the other file, immediately says, hey, you've got a file that I don't have. You've got changes that I don't have. Want to add those to the repository. It has ignored this file because I told it to. I created a .git ignore and I said, look, any file that matches this pattern, just ignore it. So we can control what Git actually does with our files. It doesn't take over everything. We actually get to control it. So Git is very good at providing support for resource management. And even if all you do is use Git locally, you've got a backup of your files, you've got the history of it, you know the differences between the different copies of it, and you have a way to safely make changes without ruining code that or files or things that you have that are already in good condition. And we get to control how and when and what Git does with the files. Now, another use case to examine is the change management use case. And this is basically going to be Git working with GitHub, so the two coming together. So one of the things is tracking the changes. The other thing is now that the changes have been made and we have the history of it, let's share it with the team. So we're going to upload it to GitHub. And notice that it's not uploading everything. You get to decide what you're going to upload. So let's take a look at that. This is change management support that we have. All right, so we know that it's just going to ignore our server log. So we close that out. This was a new file that we added in. We also had, let's close that one. This was the new file that we have on the feature branch. And what I want to do is just actually, let's take a closer look at the feature branch history. So here, let me just pull this up. Let's view the history of what's been going on. So this is the tooling. Git actually remembers all the things that you've done. So notice adding the new file got recorded in the history. It starts with the most recent and goes back in time. I can take a look at any of these things so I can see the details of it. I can actually have it open an older copy of it. So really good support for being able to manage and track your changes and all of this locally. Well, I also want to share this with my team. So let's get moving on that. All right, so I've looked at my history, I've got the changes that I want made, and what I want to do now is actually upload to GitHub. So here I'm going to push it. And it's actually uploading. I didn't highlight it quickly enough, but it uploaded the feature changes. You could see it spinning down here. I'm on the feature branch, so it uploaded the feature branch. There is an option in the tooling to say, look, upload everything on all the branches. But the default setting that I have here is the current branch that I'm on, that's the one that I want to add up. So if we come back over here, let's see, fingers crossed that that actually worked. I'm on the feature branch here. Do we see our new file? And there it is. I've got the new file. Now, if I take a look at all my branches and get a summary of it, notice that we can see here that I have the updated here. We've got different timings on that. So if I look at this and go to pull requests, I've already got one that was there, but I could also create a new pull request. And pull requests allow me to actually manage changes being synchronized with other branches, but including the team. So let's go ahead and include the team. So viewing the pull request that we currently have pending, you can see in here that it's been created, but we don't have any reviewers. So let's get somebody on our team to review. When I do this in GitHub, it will send an email to my teammate to say, yeah, you should come and take a look at it. Another role would be an assignee. So who's responsible for doing the work? Let's make these guys the ones that have to do the work. So now everybody's been told there's some pending change. We need you to take a look at it. And if you like it, please approve it. And upon completion, if everything's good, we're going to actually merge it into the main working branch. So I did the changes on feature. We have everybody look at it and like it. And then we're going to integrate it into the working branch and then up to the master branch to production. So this is demonstrating the tooling that complements Git. So GitHub has the pull requests to help us integrate our changes with the version that we want to actually put in production. So very good at the different layers of tracking the changes and then controlling, pushing the changes up towards staging to production. Now, another use case is working with project management. And I started to show you this already, but there's a lot of really nice things that GitHub has brought to the table. Let me just scroll up. I can move this guy. There we go. So if I go back, oops, clicked on the wrong one. Let's go back to our repository view. And we have here that one pull request that I showed you. So that's definitely one of the project management things, being able to control the changes. But what I wanted to focus on right now is the idea of using issues and projects. Now, you don't have to, and you can do it in any order. Like GitHub is very flexible in this. It's not prescriptive. It's not one-on-one. You can have even personal projects associated where you're tracking your own work. But think in a team setting that I have those 3 contributors to this project, they would all have access to this project. Now in GitHub, projects are really overview tools. Really, it's a roadmap to manage your tasks. You can also add in other columns. You can configure this, but the default out of the box is that the center panel here marked in progress is actually the things that we want the team to focus on right now. So all of us are focused on testing the new features. We have already completed uploading the project to GitHub and setting it up. We've already added in new features. Now we want to test them. And we're also aware of what's coming downstream. So we can see that we got to verify the product image. We've got to actually build our continuous integration scripts. Oh, that sounds exciting. And we have to complete deployment, right? So this is basically laying out the task for us to achieve our deadlines, to get our work done and to make sure that everybody knows what they're doing. Now, at the heart of working with the project are the issues. So let's go here and take a look at the issues. We said that right now we were working on test new features. And this is like, so when I look at test new features, I can actually see who was assigned the task to do this. And labels are a way of classifying the work. This is for a developer, and this is we need information, help wanted. And I have in here then all the different details, and I can actually have a conversation with other people by leaving a comment. I can leave my notes. I finished step 1, I finished step 2, so I can keep track of the work that I've done as part of this. And obviously, once we've decided that everything is good to go, we can go ahead and close the feature. Now, coming back to the issues view, it's on the issues view that I can actually set up, well, what labels do I want? Labels are that classifying, and out of the box, we have 9 that are given to us. You can edit them, delete them, as you can see down here on the right-hand side. But we can also create new labels, and when you create a new label, you give it a name, optionally a description, and you can choose the color that you want. Any valid hex code will work, or you can just cycle through their palette that they have there. And again, this is just so that we can have the visual cue very quickly, and we can actually filter. We can search on all the issues that are for developers or all the issues that are bugs. So it actually helps us manage and find the issue that's relevant to us. Milestones are also another tool for managing our projects. Milestones are really about being able to break the work down into chunks. And notice if I open up this one, phase 1, had 1 issue associated with it. It was due, well, today, 100% complete. I'm on track. Sounds awesome. And basically, milestones, when they're completed, will actually show you this nice green bar saying 100% complete. Now, notice this guy, phase 1, is 50% complete. Why? Because it had 2 issues. One was completed. Notice it's closed. Another one that's still pending. So milestones being achieved is all about having milestones mapped to issues. If I had 4 issues and I completed 2 of them, I'd be 50% done. So that green bar tracker is all about how many issues you finished. Now, I do know that in the enterprise model, you can actually weight issues so that you can get a more accurate reading of the percentage that's been done. And this, again, is part of project management. And of course, you create all the issues, and then you can actually have a quick scan of basically all of the state of the issues and bring down and being able to coordinate your work with other developers. Now, I wanted to highlight this as part of the discussion on project management just quickly. But this is basically a new feature that GitHub has. It's been around for just a few years, and it's all about doing automation. So having scripts that can automate doing tests and builds and deployments, GitHub has now entered into that realm. So that's just sort of a tease that there is a lot more with GitHub and a lot more coming. All right, so whirlwind tour, hopefully out of that, you started to get a feel for Git versus GitHub, but let's review those opening questions. So are these 2 names talking about the same thing? Now we could see that Git and GitHub are related, but they're 2 distinct technologies. Git is the distributed version control system. It doesn't require any other product to work. But it does definitely benefit by having a product like GitHub available. So GitHub complements Git by providing the implementation of the Git remote repository. GitHub says, I'm a server, put your code here. But I'm not just leaving you alone with the code there. I'm actually going to give you support so that you can review it as a team, you can talk to each other, you can manage the work that you're doing. So GitHub does bring a lot of value, which is centered around the team collaboration piece. What about the question, what are they used for? So Git is used to actually manage the project resources. And it's implemented in a way that has competed directly with existing technologies because it's so efficient, high speed, and is able to do it in a way that actually invites creativity without the risk of compromising good code. It provides backup of files and the ability to share with other team members. That's Git. GitHub says, well, when you're working with your teams, wouldn't you like some help having those conversations and keeping track of what's been said and who's supposed to do what? It's really about that project management tooling. And now they're also adding in their support for actually helping you get from your version code into production through their CI tooling called Actions. Now, how do they actually work together? How do we actually get going in this? So a typical way would be to go to your GitHub server and you set up your remote repository so that you have a starting place. And then you get each team member to install Git, not GitHub, but Git on their machine, and then use the Git tooling to actually do what we call a clone. So then they can be initialized with the starting of the project. If they're joining the team after a year of the project going, they'll be able to download a full copy of the existing project. And then now that each team member has their own local repository and they have a configuration to point to GitHub, they can actually start doing their coding work and sharing it and leveraging the GitHub tooling to have team members contribute their opinion to the code, doing the reviews, controlling the change management, and coordinating the tasks. So why are these technologies so popular? As I mentioned, like they're not the only technologies out there, but what Git brought to the version control world, first of all, it's open source. So it does invite a lot of people to get involved and a lot of people to use it. And one of their big complaints about traditional systems was how slow they were over the network, especially for large projects. So they are optimized for network transmission. They also said, like the other tools do allow this concept of branches, but they're so heavy. They're so slow. You saw how quickly I toggled back and forth. It was just a click of a button, no big deal. Git has a completely different architecture for branches. They're lightweight, they're easy, so of course we want to use them. The other bonus thing is how Git says you don't have to go to the server to get permission to edit a file. If you have the local repository, you can read and write all those files there. Work can be done offline. And then when I get reconnected again, that's when I share my work. So it does allow for a lot more efficiency, productivity, and ease of use for being creative. So grew very popular, but GitHub also contributed to the growth of the popularity of Git because it said, I know how to support teamwork. Let's collaborate, right? So they are popular because they're really addressing modern day needs. So I want to thank you all for attending, and thank you, Sarah, for being here to host the class. And did you want to explain a little bit about the offerings from ProTech?
Sure, and before we get into that, if anyone has, we do have a couple of questions that I'm going to present to you in a minute, Christine, but if anyone has any that they haven't entered yet, you may do so in the question area within the control panel in the top right-hand corner of your screen. So, but this is just a little bit of a sample of Christine's knowledge and teaching on this topic. And we do have on the screen in front of you just 3 of the classes that she's offering along with the upcoming dates for May. And in addition to that, Christine, you also do customized classes that can be tailored specifically to organizations and their unique needs, which I know that you've done that many times.
Absolutely.
Yeah. So along with the public course offerings that are on our schedule, there's also the ability to speak directly with Christine and create those she can create those courses specifically for your needs. So what I'm going to do is, do you have anything to add to those courses, Christine?
No, that's good. I think the descriptions are available on the ProTech website.
Correct. Yes. So I'm going to be sending the slide deck to everybody, and they can click on the blue course names, and that'll take them straight to the course page with a full description.
Great. And
the first.
So that, yep, question answer time. Yep.
Perfect. Thank you. The first question was, are files automatically backed up using Git?
And I think in the demonstration, I hopefully showed this, but they're not automatically backed up by Git. But Git will notify you that it sees that there's a new file or that an existing file has changed. So it's going to prompt you to make a decision as to whether or not you want Git to create that backup. So we did see that in the Visual Studio Code. So there is, again, Git is advertised as non-intrusive. It doesn't make those decisions for you. Now, if you're going, I wish it would just automate that. It's easy enough to create scripts that when you make a change to actually get it to automatically put it in the repository so that you don't have to keep going through those steps. But that's optional. Good, thank you.
Great. And the next question was, I've heard people talk about having to deal with conflicts. What are they, and are they bad?
Yes. So when you look at that picture of the Git world, if you remember that diagram where we said every team member has their own copy of the project, and then we have the additional copy that's on GitHub. So with all those instances of the project, it's possible to have 2 or more people edit the same file. When that happens, we talk about there being a conflict. Now this actually plays off of the characteristic of Git that I mentioned before about Git not being intrusive. So the first person that actually tries to basically put their files together, Git's going to say, okay, I've got multiple versions of that file. Which one should I keep? How do you want me to deal with this? So we talk about that being what we call a merge conflict. So they're not bad. It's expected when you're working on a distributed version control system. And Git gives us tooling to actually say, well, keep my copy, throw the other one out, or keep the other one, throw mine out, or even put the 2 together like this, make the sum of the parts, and then I can fine tune it after. So it does give us the tooling to handle those. So it does expect that conflicts will occur. Having said that, if the conflict occurs when you weren't expecting it, that would indicate that there's something going awry with your communication between your team members. You should have known that you're both editing the same file. If it's a surprise, you want to improve your conversation. That's where GitHub comes in and says, look, you should have an issue saying who's doing what, manage it using the tooling there so that there are no surprises like that. Thank you for that question.
Excellent, thank you. And that actually concludes all the questions that have come in. And if any questions should arise down the road, by all means, please reach out to, you can reach us on our website, and we can forward the questions over to Christine and she can help answer them. So, oh, there's another question that just came in. Okay. Will GitHub allow you to lock a file so that only one person can edit it?
Yes. You can actually do very fine-grained security around the files. Typically what we do though is we do it across branches, and especially like just thinking of it, there's a lot of different configuration you can do with Git itself in terms of large projects and dividing it down. And most of the security we would say would be around a branch. So if you have a file that you want to be managed by just one person, create a branch and make the ownership of that branch that person, then they create the file and manage it on that branch. So the way we isolate files would be through branches, and we can apply permissions to the branch that's hosting that file. Did that answer the question?
I believe so. And another question has come in to Christine. Oh, the response was that sort of answered their question. So I don't know if there's any expansion you can do on that, but.
Yeah, maybe just a summary that, is there a way to set permissions so that only one person edits the file? And the answer is yes, and we use GitHub tooling for that.
If the file is to be locked, sorry.
Yep.
If the file is to be locked, is it on the master?
No, it can be on any branch that makes sense for where you're working in your project. And we really wouldn't do it on the master. And again, it's basically, we can set up the master separately from places where we're making development changes. So can we protect the master branch? Absolutely. And anything that's on the master branch can be isolated and only certain people can make changes to it. In the same way that we can protect the master branch, any place where we're creating new code and only one person should manage that file, we would use branch permissions to isolate it. So the answer is yes, you can isolate files, but it can be where it makes sense to the work that you're doing.
Excellent. And the person that asked that question has responded saying, thank you, that answers their question. And then another question was, can GitHub go down and not allow access to your files?
With any technology, the answer to that is yes. GitHub could go down, the lights could go off. It could be a server that's actually running in a grid that fails. Maybe the lines have frozen. Sorry, giving a shout out to anybody from Texas. I hope you're safe and well. But yeah, obviously any technology can go down. But the beauty of working with Git is that you have everybody has their own copy of it. So you can continue to do your work while the server comes back up. Now, I would expect in an enterprise organization, what they would do is they'd have failover for the GitHub server. So logically, one GitHub server, but physically you would have redundancy built in there to help you mitigate those problems. But in a Git world, that doesn't mean the developers have to stop just because the server's down. So really good, already built into the design of Git to have these redundancies there. Did that answer the question?
Yes, it did. Thanks. And then another question has come in. What is Git Bash and how is it used?
Oh, I love Git Bash. And actually, if they can still see my screen, I'm going to pull it up. Here's Git Bash. Git Bash, let me just clear this out, is basically the gift from the Linux team that did Git. They say, oh, you poor Windows users, you're left with a Windows command window and it doesn't have all the really nice tools that we all like when we're in a command line. So what they did was they actually gave us a command window that has in it some of the utilities that you would find on a Linux system in their terminal window. So Bash is short for Born Again Shell, and that was basically the brainchild of a gentleman, not to be confused with the spy movies, but Born came up with, like when I'm doing command line stuff, I want different tools. So being able to do things like list all of these out, that wouldn't work on Windows. Being able to tail files, being able to look at and change permissions and things like that. So Git Bash is a version of a Born Again shell that you can use to do command line work for anything on your Windows system, but we get excited about using it for our Git projects. So learn Bash and then enjoy Git Bash. It's a utility that gets installed when Git is installed on Windows.
Another question's come in. We seem to be on a roll. How do you start Git Bash? Oh,
well, first you have it installed on Windows. Let me close it so you can actually see, because this is super easy. Let me just minimize this here. And I actually saved, no, I didn't save it on there. That's good. If you just, after having it installed, I can actually start it just by going to the Windows Start window. If I don't see it and I know I have Git installed, what I would do is I'd run the Git installer again, and it will detect, oh, you didn't choose the option to install Git Bash. Do you want to install it now? So the Git installation program, if you rerun it, will give you the options of any components you didn't choose to install. But you can see it's installed on my system. I just type Git and I just open it up like that. Easy peasy.
Excellent.
Yeah. Any other questions?
Well, that is it, Christine. I think that was an excellent presentation and certainly generated a lot of really good questions from the audience. So I wanted to thank you on behalf of Protect, I'd like to thank you for taking the time this afternoon for this presentation, and also invite anyone who would like to learn more about Git to reach out to Protect, and we can get you set up with some training with Christine.
Yay. Thank you so much, Sarah. And thank you for everybody on the call for the time that you spent today, and I hope to hear from you. And maybe we'll get to work together. So thank you very much for dedicating this hour to us.
Thanks, Christine. Thanks, everybody. Have a great rest of your day.